Okay, so let's start by discussing a lethal autonomous weapon. So the UN defines a lethal autonomous weapon as one that locates, selects, and engages or kills human targets without human supervision. Various weapons fulfill some of these criteria. For example, landmines have been used since the 17th century. They can select and engage targets in a limited sense according to the degree of pressure exerted. But they can't go out and locate targets by themselves. Guided missiles, which are in use since the 1940s, can chase targets, but they have to be pointed in the right direction by a human. Auto-firing radar-controlled guns have been used to defend naval ships since the 1970s. They are mainly intended to destroy incoming missiles, but they could also attack an aircraft with human on it. So, although the word autonomous is often used to describe unmanned air vehicles or drones, most such weapons are both remotely piloted and require human actuation of the lethal payload. Now, today, in 2025, several weapon systems seem to have crossed the line into full autonomy. For example, Israel's Harop missile is a type of missile with a 10-foot wingspan and a 50-pound warhead. It searches for up to 6 hours in a given geographical region for any target that meets a given criteria and then destroys it. The criteria could be, for example, that the target emits a radar signal resembling anti-aircraft radar, or could be looks like a tank. Another example comes from a Turkish manufacturer, STM, which advertises its cargo quadcopter, which carries up to 1.5 kilogram of explosives, as capable of autonomous hit, targets selected on images, tracking moving targets, and face recognition. So, autonomous weapons have been called the third revolution in warfare after gunpowder and nuclear weapons. Their military potential is obvious. For example, few experts doubt that autonomous fighter aircraft would defeat any human pilot. Autonomous aircraft, tanks, and submarines can be cheaper, faster, more maneuverable, and have a longer range than their manned counterparts. Since 2014, the United Nations in Geneva has conducted regular discussions on the question of whether to ban lethal autonomous weapons. Some nations, about 30 nations, have declared support for some kind of international treaty. But many nations, including the US, Russia, Israel, are opposed to a ban. So the debate over autonomous weapons includes legal, ethical, and practical aspects. On the legal side, how does an autonomous weapon discriminate between combatants and non-combatants? Or, for example, how can it decide the necessity of an attack? How does it assess the proportionality between the military value of a target and the possibility of collateral damage? Now, these criteria can change, of course. At the current time, discrimination seems feasible in some circumstances, but again, necessity and proportionality are questions that can't be answered right now. I mean, no autonomous weapon can make a judgment about the proportionality between the military value of a target and the possibility of collateral damage. That would require machines to make subjective and situational judgments, which are more difficult than the simple tasks of searching for and engaging potential targets. For these reasons, it would be illegal to use autonomous weapons only in cases where a human operator can reasonably predict that the execution of the mission will not result in civilians being targeted or the weapons conducting unnecessary or disproportionate attacks. So this would mean that for the time being, only very restricted missions could be undertaken by autonomous weapons. Now, on the ethical side of the debate, some find it simply morally unacceptable to delegate the decision to kill humans to a machine. For example, Germany's ambassador to the UN stated that it will not accept that the decision over life and death is taken solely by an autonomous system, while Japan has no plan to develop robots with humans out of the loop, which may be capable of committing murder. In the US, experts declare that it's not reasonable to put robots in charge of whether or not it takes a human life. And the head of the United Nations himself declared in 2019 that machines with the power to take lives without human involvement are politically unacceptable, morally repugnant, and should be prohibited by international law. Now, on the other side, it can be argued that as technology improves, it should be possible to develop weapons that are less likely than human soldiers or pilots to cause civilian casualties. For example, autonomous systems will not become tired over time, or frustrated, or hit with hysteria or fear or anger or revenge. And they're never going to shoot first and ask questions later. This was proven with guided munitions that have reduced collateral damage compared to unguided bombs, for example. So we should be able to expect intelligent weapons to further improve the precision of attacks. Reliability is another serious concern regarding autonomous weapons, especially for military commanders. Machine learning systems that operate flawlessly in training may not perform as well when deployed. Cyber attacks against autonomous weapons could result in friendly fire casualties, for example. Disconnecting the weapon from all communication may prevent that, but then the weapon cannot be recalled if it's malfunctioning. So there are, in addition to the legal and ethical issues, there are some practical issues as well, as you can see, with using autonomous weapons. As weapons of mass destruction, scalable autonomous weapons have advantages for the attacker compared to nuclear weapons and carpet bombing. For example, they leave property intact and can be applied selectively. They could certainly be used to wipe out an entire ethnic group. In many situations, they would also be untraceable. These characteristics make them particularly attractive to terrorist organizations, for example. So, considering all of this would suggest that autonomous weapons will reduce global and national securities for everyone. The rational response for governments seems to be to engage in arms control discussions rather than an arms race. So, as we see in AI, is a dual-use technology. AI technologies that have peaceful applications, such as flight control or visual tracking or mapping or navigation, multi-agent planning, can be applied to military purposes. It's easy to turn an autonomous quadcopter into a weapon simply by attaching an explosive and commanding it to seek out a target. Dealing with this will require careful implementation and compliance. Okay, let's move now to the issue of surveillance, security, and privacy. So, from the 1970s, experts have warned that automated speech recognition technology could lead one day to widespread wiretapping, which would lead to a loss of civil liberties. Today, we see that this threat has been realized, with most electronic communication going through central servers that can be monitored, and cities packed with microphones and cameras that can identify and track individuals based on their voice, face, and other features. Surveillance that used to require expensive and a lot of resources can now be done at mass scale by machines. So as of 2018, there was as many as 350 million surveillance cameras in China and 70 million in the United States. China and other countries have begun exporting surveillance technology to low-tech countries, okay, many with a reputation for mistreating their citizens and targeting marginalized communities. So AI engineers should be clear on what uses of surveillance are compatible with human rights and should decline to work on applications that are not compatible. Surveillance cameras, for example, as more of our institutions operate online, we become more exposed to cybercrime, cyber terrorism. So machine learning can be a powerful tool for both sides and in cybersecurity. Attackers can use automation to search for holes. They can apply reinforcement learning for phishing attempts. On the other side, defenders can use unsupervised learning to detect anomalous incoming traffic. So as attacks get more sophisticated, there's greater responsibility for all engineers, not just security experts, to design secure systems from the start. Let's talk more about cybersecurity in the next part of the lecture.